This is a differential equation problem. What's given is dB/dt, where B is the weight of a bird in grams. So dB/dt represents the rate of change of the weight of a bird. Part A asks, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? So then part A is to calculate dB/dt when B equals 70. So just plugging in 70 for B and calculate dB/dt when B equals 40. And so when we plug in 70, then dB/dt is equal to 30 over 5, or 6. And when we plug in 40, then we get 60 over 5, or 12. But what's more important here is that 60 over 5 is greater. So then dB/dt is greater when B equals 40. Therefore, bird is gaining weight faster when B equals 40. Part B says find the second derivative in terms of B. So then part B, the second derivative in terms of B, we're going to use implicit differentiation. Constant multiple 1/5 times the derivative of 100 minus B. The derivative of 100, constant 100 is 0. The derivative of negative B is -1. We just took the derivative of something that's not a t, so dB/dt. The common mistake on this problem is for students to stop there, but the question says find the second derivative in terms of B. So then we have to substitute in for dB/dt. So we can write this as -1/5 and then times dB/dt, which is 1/5 times 100 minus B. And we can leave the answer like that. Then the rest of part B says use the second derivative to explain why the graph of B cannot resemble the following graph. If we plug in any B values less than 100, greater than 20, we end up with a negative second derivative. A negative second derivative means that the graph of B should be concave down for B values between 20 and 100, and this graph has a concave up portion. So that's what we're going to say. For 20 less than B less than 100, the second derivative is less than 0. So B of t should be concave down, but this graph has a concave up portion. And then part C, we're going to take the initial condition, which was B of 0 equals 20, and we're going to solve for B of t by separation of variables. So then dB/dt is equal to 1/5 100 minus B. We're going to get all the B's on one side and everything that's not a B on the other side. So 100 minus B, 1 over 100 minus B. dB is equal to 1/5 dt. Now that we separated the variables, we're going to integrate. This is going to be a common mistake on the left side, is that students are going to forget to do u substitution. In this case, the u is 100 minus b, the du is negative dB. So we do have to multiply inside by a negative and outside by a negative. The negative dB is going to be du, and 100 minus b is going to be u. So then we have a constant multiple of a negative. The integral of 1 over u du is natural log of the absolute value of u, where the u is 100 minus b, and then 1/5 t, and then plus c. Then we're going to use the initial conditions, which were when t was 0, b was 20, which means c is negative natural log of 80. Then I'm going to go back to this step right after I integrated, and I'm going to plug in negative natural log 80 for c. So negative natural log of 100 minus b is equal to 1/5 t minus natural log of 80. And then we're going to solve. Before I can get rid of the natural log, I have to get rid of that negative that's in front of the natural log. So multiplying both sides by a negative gives me the natural log of 100 minus b equal to negative 1/5 t plus natural log 80. Now I can raise both sides as the power of e, which would get rid of the natural log. So this is absolute value of 100 minus b is equal to, and common mistake is that students want to raise both terms on the right side as the power of e, but it's the whole side that becomes the exponent of e. To get rid of the absolute value, we're going to do plus or minus. We're going to subtract 100 from both sides, or we're going to add negative 100 to both sides. Multiply both sides by a negative. Gives me positive 100. Plus or minus stays plus or minus when multiplied by a negative. And then the last thing we want to do is check whether it's the plus or the minus that would match our initial conditions of b of 0 equals 20. When I plug in 0 for t, that becomes e to the natural log 80. E to the natural log is, the 80 is 80. And then I want 100 minus 80. That would be 20. 0 is plugged in for t. So I want to keep the minus. b is equal to 100 minus e to the negative 1/5 t plus natural log of 80. The points for this come from using dB/dt, so plugging 70 and 40 into dB/dt. The explanation of where the bird is gaining weight faster, finding the second derivative in terms of b, the explanation about why that graph doesn't match the function, separation of variables is 1 point, integrating correctly is 1 point, writing plus c is 1 point, using the initial conditions is 1 point, and then getting all the way to the correct final equation is 1 point as well. That's 9 total points.